All right, let's take a look at this next one. It is just a step up in difficulty level. Notice that we have a base of 100 for this one and a base of 10 for this one. These are not the same base, but what we want to do is ask ourselves, and you want to write this down, what base do 10 and 100 have in common? And the answer to that is they have a base of 10 in common. How do I know that? Well, 100 can be written or rewritten as 10 raised to the second power. Those are equivalent. So I'm going to go ahead and do that. I'm going to say that 100 is 10 raised to the second power, and then that power is still raised to the power of that original x. And then let's leave the rest of our function alone. We already had a 10 on the right-hand side. So now I can see that my bases match. I do want to go ahead and get rid of parentheses here, so I'm going to simplify. Remember, power raised to a power, the powers multiply. So I'm going to say that the left-hand side is 10 raised to the 2x power, and that's equal to 10 raised to the negative x plus 3 power. Now that I've eliminated parentheses, I have base of 10 raised to exponent on both sides. I can go ahead and cancel these bases of 10 and just set the exponent equal to exponent. So I'll have 2x is equal to negative x plus 3. Let's go ahead and continue solving. I will add x to both sides, leaving me with 3x is equal to 3. And then finally dividing both sides by 3, I get that x is equal to 1. For this next one, I have a base of 4 and a base of 8. And 4 and 8 have a 4 in common, but I can't rewrite 8 as 4 raised to a power, because 4 raised to the first power is 4, 4 raised to the second power is 16. I've jumped all the way past 8. So I need to think of a smaller number. So what do these have in common? Well, they do have a base of 2 in common. So I can rewrite 4 as 2 squared. And I want to take that 2 squared and continue raising it to the 2x minus 1 power. And then 8 can be rewritten as 2 to the third power, because 2 times 2 times 2 is 8. So I'm going to say 2 to the third power, and that is still raised to our original exponent of x plus 2. All right, let's go ahead and get rid of the parentheses. Remember that when you have a power raised to another power, you multiply. So I'm basically going to take this power of 2 and multiply it by each term. And then the power of 3, multiply by each term. So let's see what that will look like. It's going to leave me with 2 raised to the 4x minus 2 power, and that's equal to 2 raised to the 3x plus 6 power. Again, just multiplying or distributing those exponents through. Now that I have the same base and I've cleaned everything up, I can eliminate the base and set exponent equal to exponent. 4x minus 2 equals 3x plus 6. Going to subtract 3x from both sides, which will leave me with x minus 2 is equal to 6, and then add 2 to both sides to give me a final answer of x is equal to 8.